There's no questions on homework stuff? No? It's going okay? Okay, okay. Yes? Sorry. Sorry, which section again? Which section? 3.6. 3.6. Number 36?
36.
Okay. Oh, okay. Yeah, this one I like. Basically, anytime you see, let me show you this. Oh. Have to wake up. So it says this, find values of A. So it's giving you this thing here. It's right there. So find all values of A. So there's no x-intercepts for that. Right? Okay, so that feels a little weird. It's like, what the hell? Remind me again, absolute value looks like what? When you graph it? Don't do it like that. It looks like a V, right? If that V is lowered, how many x-intercepts are there? 2. So if I just move it down, there would be 2 x-intercepts. If I don't move it at all, there'd be 1 x-intercept, right? So how would I make it so that there's no x-intercepts? Move it up. So currently, what is this doing to the graph?
Shifting it to the left.
Yeah, moving it left. And what's this doing? Doubling. And what would it make it look like? It would make it look skinnier, right? So if I just forget about A for a second, that's what this is doing, right? So basically, I just heard the answer. What do you have to do so that it doesn't hit the x-intercept, the x-axis at all? You just have to make A
Greater than 0.
Yeah. So actually, we just did the problem together. It sounds really weird when you first read through it, but you got to stop and think. We talked about exactly this, and I might have talked about it with parabola, but basically parabola and absolute value are almost the same thing visually. So if I pull it down, it's got 2. If I leave it alone, it's got 1. So if I just push it up, it's got none. So if I make A greater than 0, that would take this up, and then it wouldn't hit the x-axis at all. Okay, maybe. And of course, if you remember the video we watched, if you take into account complex numbers, it really does, but we're not taking into account complex numbers at the moment. We're just going to do real graphs. Is that all right? That was number 36, yeah, in 3.6. I like it. That's a good question because that's a weird question.
On 3.5, I got stuck on number 44. Only because we weren't doing reflections in this section, so I was confused about what they were asking.
44. Oh. Use the graphs of the transform cubic functions to write a formula for each function. So 44. Oh. I'm pretty sure, yeah.
We do use
definitely-
reflection here?
We did reflection. I think it's all transformations were in this one.
Okay.
But I appreciate that you realize it has to be a reflection.
Because the next section is reflections, that's why I was,
Oh, really? Oh.
yeah,
Yeah, you know,
that's why I wasn't sure if they
It's a
were
free book
asking me the same
sometimes.
thing.
they get a little, no, this one's absolute value.
Oh, okay, alright,
So I'm pretty sure reflections are in here.
okay,
Yeah, see right here?
okay.
Yeah. So these can get a little tricky sometimes. If you took all the transformations away, what would this guy's equation be?
X squared.
X squared, is that cool, everybody? Right, so you have to be able to start there. Take all the transformations away, X squared. Then you can start figuring out, oh, they flipped it, oh, they moved it this way, oh, they moved it this way, right? So you can start to piece together what somebody kind of threw into the x squared. This one, what is the base function here? If you took all the transformations away, do you know what the equation would most likely be? X cubed. Now we're going to talk a little bit today about that could actually be x to the fifth, to be honest. But we're going to assume it's the most basic one. We're going to assume it's x cubed. And then of course they reflected it, and then they moved it around. Is that, you guys okay with that? Maybe? Okay. And of course that would be,
X squared.
no,
Root X.
square root of x. I love it, yeah. Probably that fell over and lost its bottom half. And of course this guy would be absolute value. I love it. So that's the first step in any of these problems is can you just tell what the function is by itself? Because how could you throw stuff into it if you don't know what it is to begin with, right? Maybe. All right. Anything else from homework stuff? Interesting.
Kind of a verbal question.
Neato.
Is our one-to-one functions either always increasing or always decreasing?
Oh yeah, we actually kind of talked about this, but it was kind of quick. All right. The way to answer that is consider a function that is not always increasing or always decreasing. So if I have a function, let's say I start decreasing. If it isn't always decreasing, what must it do at some point? At some point, it's got to start to increase again, right? Maybe? Or at least stay flat for a while. The minute it even just stays flat for a minute, see how it's flat through there? Does it pass the appropriate test to be one-to-one, to have an inverse? What test do I use to see if something has an inverse? Horizontal line test. Would this pass the horizontal line test? No, because it goes through a bunch of points there, right? And of course, it'd be even worse if it was decreasing and then it went into increase. Now, that's really obvious. So I did say this semi-quickly as we were talking about inverse functions, but it does, in order to be 1-1, it has to be always decreasing or always increasing, because otherwise it comes back on itself, and that would kill its chances. Does that make sense? It's something, you don't have to know this word, but it's something we call monotonic. Mono meaning one, right? And tonic meaning drink. No, stop. Yeah, it just means one. It means one direction, not the band. Okay, I like it. Okay. Anything? Is that all right? Yes.
On section 3.7, I have a question on 18.
This guy here? Graph, the absolute of this one?
No, on section 3.7.
Oh, did I? Oh, I'm not. I'm almost there. I say that. There we go. This guy.
Yep.
Okay. So we kind of did. So help me remind me. We actually did a concrete example of this. What should happen here if I put a function into its own inverse? So for example, what's the inverse of the cube root? Cube. And what happens? Kill each other, right? What's the inverse of adding one? Subtracting one. So if I put the inverse into the function, what happens to these? They cancel, right? So what should these two do to each other?
Cancel.
They should cancel, right? What does f inverse do? It undoes what f did. So what's a function do? What's a function do? Any function you give me, when I give it a number, it's going to change it. Yes? The inverse function will undo those changes. So whatever this does to x, this will come in and undo it. So they kill each other. So let's see. So how do I verify that those are inverses? Well, I take one of them and I shove it into the other one. Let's try to do 17. Just for an example. So they tell me so if these are inverses, when I plug one of them into the other one, what should I get at the end? X. I should just get X. Whatever one did, the other one will undo. So which function do you want to put into the other one? I'll leave it up to you. You want to put F into G or G into F?
G and F.
G into F? Okay. All right, everybody take a minute to do this. Try to do that right there, and then I'll help you. Order. So in case you're having any trouble, what am I putting into F? I'm putting G. Well, I've got to know what G is before I put it in. So G is that. So I'm going to put this in to F. So I get the cube root of x cubed plus 1 minus 1. So what happens there? What's the first thing that happens? The ones die, right? Right off the bat, the ones die. And then what happens here? Cancel, so what are you off with? X. So did they do what they were supposed to do if they were inverses? Yes. So therefore, are they inverses? Yes. The funny thing is, if it works one way, it must work the other. So you could check it though. You could put F into G the other way. You could put this into here, and the same kind of thing would happen. It would undo. I really want that to make sense. Please let that make sense. Whatever the original function does, the inverse function's job is to undo that. That's why we call it the inverse. Maybe? So you can always check if two functions are inverses. Take either one and put it into the other one and see if they kill each other and have an X just at the end. Then you know they're inverses. Does that make sense? Maybe? It's okay if it doesn't. You just have to let me know. So like, for example, if we did this the other way, if we put F into G, so now we're going to put this into G. So right here, we're going to shove that in there. Right? I mean, again, if you're having any trouble with function notation, you desperately have to come see me. We all have to be cool with function notation because all it is whatever the hell that is, just shove it right there. Right? That's all it ever means. It is so single-minded. So I replace. So I have something q plus 1, and the something is this business. Now what's the first thing that happens this time? Cancel what? Yeah, the cube and the cube root cancel. And of course then, minus 1 plus 1 cancels. So did these basically kill each other? Yes, because I was just left with x. I really want that to make sense. Isn't that what the inverse function should do? Right? It should annihilate each other. It should cancel each other out. Maybe. So now you can do number 18. Same way. Okay. Anything else? How do you tell graphically if something's one-to-one? If something has an inverse? We just said it earlier. Horizontal line test. What's the vertical line test do? to see if it's a function, right? And I really want this to make sense. The reason the horizontal line test exists, if I took a parabola and I flipped it like I would for an inverse function, it wouldn't be a function. So instead of flipping the function and doing the vertical line test, we just flip the test. We'll do a horizontal line test. Instead of flipping it and then do vertical, just don't flip it and do it horizontal. That's all it is. It's almost like, okay, that's what you crazy people want to do, sure. Okay, maybe. Anything else from homework stuff? All right, okay. So last time we did like a basic review of graphing, lines and such. I want to there's a couple things I need to finish up from chapter 4, and then we're going to get into chapter 5. And by the way, if you didn't see this, the test is moving. It's supposed to be next Wednesday. There's no way in hell we're going to do that. We're going to push it back to Tuesday, and we'll see. We'll see if I get through chapter 5. So we'll know exactly what's going to be on the next test by the end of next week. Okay. This is definitely something. One other thing, can somebody tell me what's just the general equation of a line? Yeah, so one equation of a line is this. And remind me, what does this tell you? Slope. What's this tell you? So if I gave you this, how do you tell me what the slope is? What do you do?
Minus 5x.
Say again?
Minus 5x.
Yeah. So you start to solve for y, of course, because this happens a lot in mathematics. Later this semester, we're going to look at equations of circles. I think I already threw that at you once. But if I have a circle equation and I put it in the right form, I can look at the equation. It tells me the center and it tells me the radius, because that's the two most important things about the shape. Since an equation creates a graph, the equation, if it's in the right form, should tell me the most important things about the graph, because it creates the graph. Does that make sense? So for lines, if I put it in this form, the two most important things about a line is, where's it going? That's the slope. And where does it start? That's the y-intercept, right? You guys kind of with me? So if I put the line equation in the right form, those two things should just come shooting out of me. Maybe. So, like you said, subtract 5x. I'm going to shove the 5x in front because I know I want that to be in that order so I don't make a mistake. And then what's the last thing I have to do to get y by itself? Divide by -4. This is where, well, that's good. This is where a lot of people make a mistake here for some reason. These two negatives do what to each other?
Cancel.
Yes, let them die. So this would be 5/4 x minus 11/4. So what is the slope of this line? 5/4, right? Just because it's in the right place. That's crazy. That's crazy. The number just is in the right place, so that's the slope. And so the slope is 5/4. What's the y-intercept?
-11.
No. I know, I'm being a little picky. Too bad. Try again, what's the y-intercept? Yeah, there we go. 11. Oh yeah, you are. Okay. And I know. Some of you guys are like, oh, whatever, man. But you have to remind yourself it's a point, right? And I'll show you later why that's a huge concern. Maybe I'll show you now. Yeah, let's do it right now. So pretty cool. That's the basic line. One thing before I go to the next equation, there's another equation of a line. I want to see if anybody knows it. So hold on to that if you do. Let me show you one other thing related to what we just did. Can somebody remind me, if I want just the x and y intercepts, and I give you some equation out of nowhere, what do you got, Jeff? I don't know, man. Sure. I just want the x and y intercepts. That's all I want. Right? How do I find those? Who remembers? I always do the same thing, yeah.
Plug in 0.
Yeah, so if I want the x-intercept, what do I put in for 0?
Y.
Yeah. So then I get negative 2x plus 7 times 0. That goes away, divide by negative 2. Now, I'm not going to do anything further. I'm going to make a mistake here in a minute. Is everybody cool with that so far? What about the y-intercept? Set x to 0. I love it. And that never changes. I don't care what math you're in. You want to find a whatever intercept, you make all the other letters 0. It's crazy. That goes to 0, divide by 7. Now what I always get is somebody, and then if I ask you to graph this, I always get somebody that graphs this point, and then they're like, put a question mark, like, what do I do? Where did that point come from? Is that a point on the line? Where did that point come from? They put this with that. Are these two things related?
No.
This and this? I really want you guys to see. So that's not correct. Let me leave this here and say, hell no. What's the x-intercept? What is it?
Negative 14, 0.
Negative 14, 0. What's the y-intercept?
0, 4.
All right, so that's why, it's one reason why I'm really picky about if your answer is supposed to be point, write it as a point. Because then if you don't, it leads to really easy mistakes later. Okay. I like it. Because how can you graph a line if I just give you 1 point? I agree, you can't. But you do have 2 points there. You can plot those and connect them. Okay, maybe. All right, now. So we got the one equation, y equals mx plus b. This will be here in a minute. We'll talk about these. Does anyone know a different equation for lines?
Y minus Y1.
Yeah.
Equals m times x minus x1.
I love it. Now, real quick. Has anybody ever seen this before? It's okay if you haven't. Does this look vaguely familiar? Does anyone know where the hell this thing came from? Say again? Okay, that's the name of it. Does anyone know where it came from? And do you see why we call it point slope? Because math people are really creative. What's this again? Slope. And what's x1, y1?
Point.
The point. So math people were like, oh,
What do we call this? It's got slope and the point. We'll call it point slope.
right? Okay. That's exactly how we sound. Real quick. I want you to understand where the hell this thing came from. What's the formula for slope again if you have 2 points?
Y2 minus
Yeah, y2 minus y1 over
x2 minus
x2 minus x1. Now, what are the little subscripts again? What do little subscripts mean? The little 1 and the 2, what do those mean? Say again? Points, the points. There's 2 points. So there's an x part of the 1 point, there's an x part of the other. You guys with me? That's all they freaking mean. If I have a line, does it matter which 2 points I pick? No, I can pick any freaking points. It's got to come out to be the same number, or else that's not a straight line. Somewhere it's curving if it comes out different. Are you guys with me? If I have a straight line, it's the same freaking slope everywhere. So it does not matter what points I pick. So what we do is we say, all right, sure, we'll have 1 point. And then we'll say, you go pick any other point you want to anywhere. If it doesn't have a subscript, that means it's anything. So if it has a subscript, it means it's a specific thing. That's the 1 point I'm given. This is any other freaking point. Is everybody cool with the fact that if you pick any 2 points, it's going to come out to the same number for any given line? It's got to. I love it. And then if you just multiply this up, you get that. So how the hell do you use this thing? All right, let's talk about it. All right. What if I wanted to find the equation? By the way, this is shortcut for equation. I'm just gonna do that sometimes, so I might as well just tell you, is that cool? That's equation. Find the equation of the line that goes through, I'm gonna spell through like that. Where's my English people, I'm sorry. And 3, 6. Ooh, I like it. So this is a potential problem that you'll see in the homework, you'll see on the test, you'll see in the quizzes. So what two things do I need for the equation of the line? I definitely need the slope. And I need a point. If it's the y-intercept, that kicks so much ass. If they give me the y-intercept, that means I know what b is. Is that cool? I don't have to use this funky equation. If they give me some other point, I don't know what b is. Right? And I'll show you a different way to do it in a minute. I need a slope and I need a point. Do we have one of these?
Mhm.
Yeah, we got one of them in spades. I got 2 freaking points. Somebody pick one of the 2 points for me. Either one. 3, 6, okay. Check. All right, we got the point. Now how do we get the slope, of course?
1, 2 minus 1, 1.
Yeah. All right, take a minute, don't say anything, figure out what the slope is. All right. Yeah, so how did you get 5 back there? What'd you do?
6 minus -4.
6 minus -4?
Over 3 minus 1.
3 minus 1, I like it. Right, and then what's 6 minus -4? 10, right, because this becomes plus, and then 3 minus 1 is 2, so you get 5. All right, so now we get the slope, and we got a point. So real quick, I really want you to notice this. One of the major things I always try to say in mathematics is the people that kind of naturally break things into parts have a much easier time with mathematics, right? If you don't naturally break things into parts, you're gonna have a harder time with math. So they give me all this shit, and then I go, I'm gonna focus. I need the slope. Let me just worry about that by itself. And I need a point. Let me worry about that by itself. So now I've got both of those things, right? So, how do I use this equation? I know the slope is 5, and I know the point. What's the x piece of the point that we picked? And what's the y piece? So now I can do y minus the y piece equals m times x minus the x piece. And then you can just kind of clean that up. So hopefully this is familiar to a lot of you. So now you get y minus 6 equals 5x minus 15, add the 6. Okay. How do you check this, by the way? How do you kind of check this? Which point did we not use? 1, -4, right? If we're right, what can I do with this to see that we're right?
Plug it in.
Plug it in. It should work. So if I put a 1 in, 5 times 1 is 5, minus 9 is -4. It works. So if we would have chosen this here, believe it or not, that would have come out to be the same number, and then we would have plugged this in to see if we were right. Okay, maybe. Okay, so something I can never read you guys if you're bored, if you're completely confused. Let's talk about these ideas here. Parallel, perpendicular. What's true about 2 parallel lines? Tell me anything. They never touch.
They have the same slope.
Same slope. So two parallel lines, so they never touch, they're always the same distance apart. So they must have the same slope, because if the slopes were different, one of them is going to catch up with the other one, right? And then they would touch. So the slopes must be exactly the same. What about perpendicular lines? What's the perpendicular line to that? What's it got to do if it's going to be perpendicular? True, but what's it got to look like visually?
Must have a right angle.
See again?
Be
Must have a right
adjacent to
angle.
each other.
Right angle, I love it, right? So it's got to, so this has got to be a right angle, right? Now this one's kind of more interesting. Obviously the slopes are not the same. In fact, they are completely opposite. So what do I mean by that? If this slope is 2, this slope has to be, what are the opposites? How can you make a number opposite? You can change the sign, and you can flip it. So we do both of those things. We make it completely opposite. So what's the negative reciprocal of this? Negative 1/2. Cool. Cool, cool. So it's kind of nice. Parallel, exactly the same. Perpendicular, completely opposite. Okay. So real quick, are these lines parallel or perpendicular? Or neither? What do you got, Jeff? I like it. Why can't you immediately answer that question? What do you have to do to answer that question? Find the slopes. I love it. And how do you find the slope really quickly? Solve for y. Kick ass. Do it.
Is that minus 11 or plus 11?
That's 11.
No, is it plus 11?
Sorry?
No,
It's equals.
yeah.
Sorry. Yeah. So if you solve the first one for y, you should get negative 3/2 x plus 5/2. Is that what you guys got? And for the second one, if you solve for y, you should get negative 2/3 x plus 11/3, I think. Are those parallel? Hell no, they're not the same number. Are those perpendicular? No, good, so it's neither. I love it. In order for them to have been perpendicular, you would have just needed one of these to be positive. Is that cool? So you're gonna see some problems that say, are these lines parallel or perpendicular? That's all you gotta do. Solve for y, see the slopes, see how they relate. Okay, now, next level problem. Right, that's a pretty basic level problem. Just find the slopes and see how they compare. What if I ask you?
Quick question.
Yes.
Is it possible for a perpendicular to be like both slopes to be positive to be perpendicular?
No.
That's all.
In fact, I mean, do you see how, can you imagine how many ways you can create like this X? And the minute, so the best you can do is that one this way and one that way. What would this slope be? Zero, right? A flat thing should have a slope of 0, correct? Does anyone know what this slope is?
Undefined.
Undefined. otherwise known as, anybody else call this a different slope? Infinite. It rises without running at all. So it's infinite, like, boom! It's like instantly to infinity. Holy shit. All right, so this is infinite slope. Why does that make sense? Aren't they perpendicular? How are they supposed to react? Shouldn't this one be the negative reciprocal of this? What's the reciprocal of 0? True, but why? Be more direct. What's the reciprocal of 0?
1 over 0.
1 over 0, and then negate, so negative 1 over 0, which is undefined, but it's also infinity. It's infinite. Are you guys semi with me? And then so I really want this to make sense. That's negative, that's positive. As you turn it, it's still negative and it's still positive, right? And then you get here, and then the minute you turn it a little more, now this one's positive and this one's negative. So there's no way, that's actually a really beautiful bonus question. There's no way for two perpendicular lines to have this, to both have positive slopes. There's no way. Okay, maybe. Oh, okay. So what if I ask you this funky ass question? Find the equation of a line that is perpendicular to, what do you got? 5x minus y equals 2, and has the same x-intercept as 4x minus 111y equals 28. So again, break it up. You don't have to worry about everything in the problem all at once. What two things do you need? I'm sorry, let me let you copy the problem now. You know, like, be quiet for a minute, Jamar. This one's really much more difficult than the one we did earlier, but at the same time, it really isn't. So what two things do I need? Oh, okay, in general, anytime I see this, find the equation line that does stuff. What two things do I need? Slope and a point. Okay, I love it. Now, you look at the problem specifically and you say, okay, what information did they give me that relates to my line slope? So what piece of information relates to our slope?
5x minus y plus 2.
Yeah, why does it relate to that? Because we know our line is perpendicular, so that piece of information will tell me my line slope, right? So if only I knew what, then I could figure out our slope. So if my line is perpendicular to that line, what do I have to know first so I can figure out my slope?
The slope of the percent.
Slope of that line. Yeah, if I knew this line's slope, my slope would be the negative reciprocal, right? That's how perpendicular slopes react. That's how they relate. You guys see this? So one mistake students make is, for some reason you see a problem and you think it's all supposed to be in your head at once, and that would drive anybody insane. I am at first not going to care about this stuff. I've broken it up. Slope, the only thing that relates to slope, perpendicular. Okay, so I got to figure this guy's slope out, then I can see what my slope is. I don't give a crap about anything else. So how do I figure out this guy's slope?
Subtract all the-
See again? Yeah, subtract 5x, divide by -1. I would rather add y, subtract 2. So what's this guy's slope?
5.
So what's our slope?
Negative
1/5. All right, cool. Not the slope you wanted, but the slope you needed. Now, do I just give you a point? We need a point, right? Did I just give it to you? Right, like the first problem, I gave you 2 points. You can pick. This problem, I didn't give you any, too bad. But did I give you information that leads you to a point? Yeah, we have the same x-intercept as this line. How do I find that line's x-intercept?
0.
Yes, set y to 0. So what's this line's x-intercept?
X comma 0.
Well, yeah, so 7, 0.
Sorry, 7, 0.
Check, check. All right, so now we got our slope and we've got our point. Is that all right, guys? So of course, this is of course a math teacher would love this problem because it's one problem that's got multiple steps, right? Every student's favorite. But each step by itself is not, if I just said, what's the perpendicular slope to that line, you should be able to do that. Find that line slope, do the negative reciprocal. If I said, what's this guy's x-intercept, you should be able to do that, right? Set y equal to 0, 4x equals 28, not a big problem. Now that we got these two things, let's take a minute and try to plug them in here. I know there's a fraction, I don't care. This wasn't that bad, right? It really wasn't. There's not much to do with the fraction besides. Multiply negative 1/5 times negative 7 plus 7/5. Right, fractions showed up, but we didn't care because the minute they showed up, we were done. Right, that's the best time for them to show up. Okay. All right, maybe. You guys remember these kind of problems? Find the equation of the line that does stuff. You just have to find these two things. These are each their own problem, and then you just put them all together. Okay. Okay. Yeah. Okay. So anything about that? That's the last couple of things from chapter 4. The idea of parallel and perpendicular and how they can show up in problems. And by the way, just to remind you guys remember that I put the lectures up on the YouTubes, right? On the internet. So all these lectures are up on YouTube. Link is in the Canvas shell. Okay. Nobody's all in. So the main part of today is I want to get into chapter 5. Chapter 5 is where the pre-calc really starts to come in. Chapter 5 is going to be where we're going to start graphing polynomials of any degree with some kind of specificity. We're not just going to, there. we're gonna actually figure out kind of where this is and what it does and so forth, right? So we have to talk about all the various aspects of a polynomial shape. So let's start with the most basic polynomial, right? Start with parabola. So we already know quite a few things about a parabola. In fact, let me remind you of one of the most basic things we've already done. Remind me, for this, where's the vertex for just the standard x squared? Yeah, 0, 0. That's beautiful. Right, whoop-de-doo. So that's one of our basic graphs. We have to know the shape so then we can move it around. Can somebody tell me if I have this what are the transformations? I'm telling you, there's 3 of them, right? What are the transformations? Left 3, 11. Double outputs. And then down 11. Now, I'm not going to graph the whole thing using transforms. All I want somebody to tell me is where's the vertex now? Here the vertex is at 0, 0, right? So again? Yeah. So what does every point do? Every point goes back 3, left 3. So now we go back 3, and then it goes down 11. And of course, the doubling for the vertex, it's 0 output, so when you double it, it's still at 0, so that doesn't do anything to it. Is that cool? Or is that understood? Okay. All right. I'm not going to say it's cool. So we don't necessarily have to think of it as transforms now, unless it specifically tells me use transforms to graph this. So if I just give you a function, parabolic function, look at that one. You want to graph that one? I don't. Can just take a minute. Why did I do the exact same? What would the vertex be? It is weird. I don't care. What's the vertex? That's all I want to know. Negative 1.1 because it goes back 1.1.
Y is root 2.
It goes down root 2, yes? Right, gross, but if all it wanted from me was a vertex, sweet, there it is, I'm done. Right, that's the vertex. Does this one open up or down? Do you guys know?
Down.
Why is it open down? Because that first coefficient is negative, so it's going to flip it. It's going to be a reflection, correct? All right, one more. We make these better numbers. 3, 4. Go back to F. 2x minus 4 squared plus 3. Yeah, so it's going to go right 4, up 3. It's that straightforward. So let's gather some general information we just figured out. If I have general observations, if I have a function, a quadratic function that's in this form, what's the vertex? Say again? Yeah, H, K. And does it open up or down? It would open up if what? If A is greater than 0, and it would open down if A is less than 0. Cool. That's some really cool shit just to tell If it's in this form.
What do you mean by open?
Parabola, if I drew a parabola like this, which way would you say it opens? Would you say it opens up or opens down?
Up.
Yeah, there you go. It's kind of a weird thing to say in words. I had to go to a visual. Okay, maybe. Not too bad, right? I mean, that's just straight off the transforms, and now maybe you start to see why the hell we talk about transforms a little bit. So, two things. Can somebody tell me what the y-intercept of this is? Using the same function. Say again?
0.3.
No. This form is beautiful for vertex, but it sucks for intercept, at least y-intercept. What do you do to find the y-intercept? You set what?
X is 0.
X to 0. What happens when you set x to 0? You just get 3? No, because what, isn't this stuff? Negative 4 squared is times 2 plus 3? Oh shit. So this form kind of sucks. We're so used to just looking at this last number, but I can't, because when I make x 0, that first piece doesn't go away. Damn it. Damn you problem. Okay. What about the x-intercepts?
Y.
Make y to 0. Where's y in this equation?
Not there.
F of x. So if I make y 0, how do I start to try to solve this?
Moving stuff over to isolate the x.
Yeah, subtract 3. What can I tell right away? Do you see why there's no reason to keep going? Does anyone see why there's no reason to keep going? Yeah, so this side's negative. This side's always going to be not negative, correct? Aren't I squaring something and multiplying it by positive 2? I can stop right there. There's not going to be any x-intercepts. Do you guys see that? So of course, if this had been a negative 2, I could divide and then I can square root. I could get x-intercepts, but right there I can tell I don't need to keep going. It's impossible. That doesn't work. So there's no x-intercept. So what does this parabola look like? Does it open up or down? Up. Could it be here?
No.
Why do I know it can't be here? Because we just figured out that it has no x-intercepts. Right? It has no x-intercepts. So it must be somewhere up here, right? It's got to be up there somewhere, so it doesn't hit the x-axis. Okay, and of course, I could be much more specific because I know the y-intercept. Let's see. All right, let's try this. Let's make a better graph. Because I really don't want you guys to think that that is anywhere near acceptable if the question says graph this, right? That is preaching. And then you can say, well, you did that, Jeff. I know. So let's do a better one. What's kind of like the most important point for a parabola? Vertex. Now, what's going to suck about graphing this?
Scale.
The only other thing I know is the y-intercept. 0, 35, right? So my scale is going to be a little wonky. What kind of scale do you guys want to use? Go by you don't want to go by ones, correct? If you do, don't. I don't want to see that. Go by tens? Maybe got a little bit better. Fives maybe.
Threes.
Threes, no. Let's go by sixes. Oh, I need to go further. Crap. All right, let's make this a little better. Six, 12, 18, 24, 30, 36. So 35. So 0, 35 is right there. The vertex is at 4, 3. So it's about halfway there. Is everybody with me so far? Now, another really kick-ass thing about parabolas is they have kind of an internal mirror, right? Where's the mirror for a parabola always? What does it run through? The vertex, right? So any parabola you draw, how is it symmetric? Right through the vertex, correct? So there's a mirror. Does anyone know what the actual name of this is? Axis of symmetry. Kind of makes sense. It's the axis, it's the line around which this thing is symmetric. Okay. Anyone know what the equation is for that axis of symmetry? It's a line, correct? And it's a line that goes straight up and down. X equals 4. Doesn't it go right through 4? Goes right through the vertex? And it's straight up and down, that's x equals. Okay, so what's the only way you would have a y equals axis of symmetry is if you had a parabola that opened sideways. We're not going to worry about that yet. Okay. So where should there be another point? I don't have to do any real work to find one more point, because that's the mirror, correct? That's a mirror. So that point doesn't help because it's on the mirror. So where's its reflection? Right there. Damn it. Do I have another point? Do I have this point?
Mm-hmm.
Where must there be another point then? How far is that from the mirror? 4. So where's the another point? 4 away on the other side. Now I've got my parabola. Oh shit, make that big. So you can find the y-intercept relatively easily. You can find the vertex if it's in the right form. And then you've got an automatic third point. Just the mirror image. Maybe? A lot less work to do. I don't have to plug stuff in to get that last point. Maybe. Okay. So we'll do more of this. I want to, let's see, kind of like my modus operandi is tomorrow we'll kind of have a worksheet right at the beginning that's going to have all this stuff for you to practice. So I want to, let's go to another idea here, because do we always get quadratic functions looking like this? Nope. Right? So a really good question would be, how do I put it in that form if it's not given to me in that form? Okay, so I'm going to erase all this. Maybe I'll keep this up. All right. So I want to put this into standard form. And standard form is that. So I don't know, maybe somebody out there realizes what's going to be involved here. So let's review that real quick. What's going to be involved here is the thing called completing the square. By the way, all right, we are going to develop some shortcuts, but right now, why would I want to be able to do this? Because when it's in this form, what can I see?
The transformations.
True, which leads me to see the vertex, right? So it's sort of like solving for y with a line, because then I can see the slope and the y-intercept. So if I put it in that form, I can see the vertex. So completing the square, real quick, how does that work? So if I have this, do you guys remember how to complete the square? Well, how do I figure out what goes here to make it become something squared? I believe we did this. No?
Take the half of that.
Yeah, whatever the middle term is, you take half of it, so that's -2. The really cool thing about that is, that's the number that makes that. The first step tells you what the answer is going to look like, and then what's the second step? What do you do to this? Square. So that's what you add here. So if you add this here, it factors like this. That's completing the square. Okay, maybe. So how does that apply to problems we're going to look at that involve parabolas? So let's take a look. erase this here. Again, there's a whole sheet, I'm pretty sure I put it up in Canvas, I think I might have given it out too, I can't remember. Alright. So if I'm given this here. Can you factor that? Well, if you can, you're better than me. Tell me how to factor that. Because what would you need to factor this? You need numbers that multiply to be 6 and add to be 6. There are such numbers, they're just not nice to look at. You guys with me? They might even be complex or something. So, all right, let's give up on that for a minute. So I want to complete the square, because if I complete the square, this chunk is going to look like this. And then I can see the vertex, right? So there's motivation as to why to do this. So what I'm going to do first, I'm going to make some freaking room. Move that 6 out the way, right? That's going to be a part of this at the end. You guys get that 6 out the way. Now do the 2 steps. What are the 2 steps? Take what and cut it in what? What are the 2 steps?
Take the 6.
Take this 6,
Cut it in half.
cut it in half. And then what do you do to that? Square. Always. That's how completing the square works. So this tells me what I have to add. Now watch. Am I allowed to just, do you like there being a 6 here? Can you just change it and then keep working? Can you just change the 6? I don't like that 6. Let me change it. Can I? No, I cannot do anything that's going to make this a different problem. So if I do this, if I add 9 right there, what must I do at the same time? If I don't want to change this, is this currently different from what it was? Isn't this 15 now? Is this 15 now?
Yes.
Was it 15?
No.
How much bigger is it now? Of course, it's 9 bigger. So what do I do at the same time so I end up not doing anything? If I add 9, I better subtract 9 at the same time. Now, some of you guys are like, okay, this is like, move that barrel over there. Now move that barrel back over here. It's like, what? But how do I factor this now? How do I factor this? Yes, this always tells you how it's going to factor, and this always tells you what you have to add. So this is x plus 3 squared, and this will be 6 minus 9. Yeah. Right? If I multiply this out, I get this. And then if I subtract 3, I get this. So it's the same function. I haven't changed it at all. I just made it look different. Why is the way it looks better now? Can you tell me what the vertex is now?
3.
Say again, sorry?
3, -3.
Not quite. This would move it
-3.
back, yeah. Okay, maybe. So again, since I want to collect all my x stuff together in a square, it makes sense I want to use the process called completing the square, because that's what it does. It takes all the x stuff and makes it into x plus or minus something squared. It's beautiful. Then it's going to be in the right form. Now there is a shortcut to this, but this is fine because we have to know how to complete the square for later anyway. Okay. I don't know if anybody knows the shortcut, but we're getting there. Let's finish this thing up. So that's the vertex. Can anybody tell me there is something really nice up here that you can just tell me what the y-intercept is really easy? Can you tell the y-intercept really easy here? Not necessarily. Can you tell it easy here? Yeah, because how do you find the y-intercept? You make x 0, so what's the y-intercept?
6.
0, 6. You're all like, is he having a conniption? What's happening? All right. I know, it seems picky, but again, you gotta get in the habit of identifying things as points, right, if they're a point. Okay, what if I ask you for the x-intercepts? So we did this earlier, right? How do you find the x-intercepts? Yeah, so y equal to 0. Am I gonna get real answers this time? Because what's the first step?
Add 3.
Add 3. Then I can take, do I multiply this out? That would be crazy. Because what can I do right now to both sides? Square root, right? If I put a square root, what do I have to put at the same time? Plus or minus, yes, it's gotta become a habit. It's gotta feel wrong to not do it. So now I have plus or minus rad 3 equals x plus 3, so the last step is subtract 3. Now, do these look nice? No. If you had to graph them by hand, you would just plug it in the calculator, -3 plus rad 3 and -3 minus rad 3. And then you can kind of approximate where those are, correct? Okay, like it. But do I even need these to graph this? Do we even need these? What do I have already to help me graph this? You guys still see this? Yeah.
You have a vertex and a point.
I've got the vertex, and I've got the y-intercept, yeah. That's all I really need. So, let's see. Vertex is -3. Everything's happening back here, Jeff. Shit. All right, so the vertex is -3, -3. Okay, there it is. Okay. Second, -3, -3. The y-intercept is
0, 6.
0, 6. And now you see why I went out 6? Because I know what I'm going to have to do. I'm going to have to find the mirror image. Where's the axis of symmetry? What's the equation of the axis of symmetry?
X equals negative.
Yeah, it's just x equals the x piece of the vertex, because it has to run through the vertex. So it's x equals -3. That's the axis of symmetry, A of s. And how do I find one more point that's on this? Well, this, how far away from the mirror is it? 3. So there's another one that's 3 over this way. And then I've got my wee-ha. Overall, that's terrible, but for me, it's pretty good. Man, they're really big. Okay. How do you guys feel over this? I mean, this is kind of nice. When you can get a point without doing much work, you just freaking, oh, there it is. That's beautiful. And because parabolas are symmetric, they let you do that. All right, okay, all right. Now, let's do one more example of this. A grosser example, really gross. I'm telling you right now, this one's going to be gross. Okay. This one is going to be gross. So then we'll develop a shortcut, right? That's what math people, that's what we like to do. Here's a really hard shit, and then we'll show you a shortcut. So what if I had to put this into standard form? What do you got, Jeff? Let's not make it too gross. Yeah. That's not bad at all, Jeff. All right, whatever, Jeff. Sure. Yeah, okay. So I want to put this into standard form. There's an issue here. There's a problem, right? That wasn't present in this first one we did. See how this number's a 1? Yeah, damn it. So, be really, 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 really careful. The very first thing I want to do, I want to move that -4 over a bit, leave some room, right? But, what do I do about the 3? I can't have a 3 here, so what do I have to do? Take it out. 3, get out of there. 3, okay, there we go. And what's left in here? X squared minus 4x, okay. I like it, so there's some room right there. So completing the square is built on the first number being a 1. That's how it's hardwired. So if there's not a 1 there, I've got to get that out the way. Now inside, let this be easy. What are the 2 steps to figure out what I add here? What's the first step? Take this and divide it by 2. Second step. Take that and square. So that tells me what to add, and this tells me how this is going to factor. That kicks ass. So right now, get out there, negative. I know this is going to factor like this, right? Bam, bam. That kicks so much freaking ass. What I'm worried about is what's going to happen now if I put that +4 right there. This is so weird. What is wrong if I put a +4 and then do a -4? Why is that wrong? Isn't that, somebody could say, that's exactly what we did before, Jeff. Not really. If I put a +4 here, did I actually just add 4 to the equation? Or did I add 12? Didn't I just add 12? If I put a +4 right there, 3 times 4, I actually just added 12. That's what I just did. Do you guys see that? So what do I better do at the same time? Subtract 12, so that overall I did nothing. So why was the first one not that hard? Because what's the number in front? A 1. So this was 9. So I just had to subtract 9. The number out front didn't mess me up. This one, damn you. So what's it now? So the 3, this factors like this. That kicks a whole bunch of ass. And then out here I get how long? Okay. What do I get over there?
16.
All right, minus 16. So what's the vertex? Say again, sorry? Yes, 2, -16. I love it. Does this do anything to my vertex? No, because that's the left and right, and that's the up and down, and that doesn't really affect that. Not for the vertex, it's at 0 to begin with. And then I can ask you, what's the y-intercept? Anybody see it real quick? 0, -4. Right. And then you can plot the vertex, you can plot the y-intercept, you can make the reflection point. Okay. I'm not going to do all that again. Yes?
So I'm confused because I don't really understand how you got the 12 there, because I thought that you cut the 12 in half and then square it.
No. All right. It's not this that we're working with. I can't work with this
Okay.
for a complete square because that's not a 1.
Okay.
Very first thing is we took a 3 out of these.
Okay.
So what am I actually working with?
Okay.
-4.
Got it.
-4 cut in half, blah, blah, blah. So if I add 4, are you cool with I actually added 12?
Mm-hmm.
Okay. All right, maybe. Now, do you wish there was a quicker way to get the vertex? Does everybody really enjoy doing this? Can you imagine if that would have been 11? Then this would have been 11/3, and you had to cut that in half and square it. Do you want to do that? I'll answer for you. No, I'd rather not, Jeff. Do you have another way? No, yes, I do. What's the, well, all right, let's do this. Help me with something and I'll get you a shortcut to find the vertex. Help me factor, let's help me factor that guy. He's actually factorable, right? So don't say anything. Just take a second, factor that guy, and then I'll ask you. All right, now tell me, how does that factor? Yeah, that's nice. It's crazy nice. Can somebody very quickly now tell me what the x-intercepts are? Say again, sir? 3, 0, and 1, 0. Okay, so real quick. Right now, if I wanted to try to graph this, all I know is this, correct? That's all I know right at the moment, right? Can you tell me if it goes like this or like this? Does it go open down or does it open up? It opens up, right? Because it's positive. Okay, that's great, Jeff. But why don't I just do this, right? It's not specific enough. What am I still missing? The most important point. Vertex. Now, where must the vertex be in relation to these 2 points? Right in the freaking middle. Why? Because the vertex is where the mirror is, right? Okay. So what's the x value of the vertex? I know the vertex is 2 comma something. Does everybody see that? If I know the x-intercepts, the x value of the vertex must be right in the middle of them because it's the frickin' mirror. Of course it's right in the middle of them. Let that make too much sense. Now, so how do I complete what the vertex is then? How do I figure out what the y piece is? Well, what do I do anytime I know the x? Put it in, right? I'll do this one. 2 minus 3 is -1 times 2 minus 1 is 1, so -1 times 1 is -1. Ciao. That's kick-ass, right? And it verifies that it opens up, correct? So if you do that process wrong, you'll quickly see if it's opening the wrong way. So are intercepts always this nice? What were the intercepts for this problem that we did? That, okay. What's in the middle of these two? So, watch this. What process? What do we use for something that looks like this, whose job is to find the x-intercepts? We could do this. What do we use on that? The job of which is just to find the x-intercepts. And that might be a weird question. How do I solve this equation? What do I use if I can't factor it? Quadratic formula. What's the quadratic formula? All right. If you don't have it memorized, you need to memorize. Make a little song out of it, whatever. Right. And I'm pretty sure, didn't I put you through the derivation of that? I'm pretty sure we did. I can't remember. We've done a lot of stuff. Okay. Now watch this. I'm going to write this a little bit differently. Can anybody tell me, is this the same thing here that I'm writing? Is it the same? Have I changed it at all? Can't I just break those fractions up? Isn't that this fraction plus or minus this fraction? So this is a number plus or minus this thing. So isn't this right in the middle, right? And again, remind me, the x piece of the vertex will always be right in the middle of the x-intercepts, correct? These are the x-intercepts. And what's right in the middle of them? Negative b over 2a. So I don't know if anybody remembers this. X equals negative b over 2a is the shortcut to find the x value of the vertex. Oh my God. So, do we already know this guy's vertex? Yes. It was 2, -1, correct? The one we just did. Cool? No. Okay, well, it was. Let's try this shortcut. So the shortcut is x equals negative b over 2a gives you the x piece of the vertex. What is b in this equation? What's b? Negative 4. And what's a? 1. 4 divided by 2? 2. A. Right? And then you would plug it in and get negative 1. So you get the complete vertex. I don't know if this is familiar to anybody. So for example, if I gave you this, let's do that guy. Yeah. All right, so if I want to find the vertex, to find the x piece, I can use the shortcut, negative b over 2a. What's b? Negative 12, right? And again, if anybody's mystified as to how we can figure out what b is, it's because it's always ax squared plus bx plus c. And what's a? 3, right? So I get 12 divided by 6, 2, which is what we got. Much quicker though, yes? Maybe? Okay. So if the question wants you to find, can somebody tell me, do we know enough yet for you to answer what is the minimum value of this? I want to know the minimum value of this. Why does it have a minimum? Because it opens up, so wouldn't it have a minimum? Do we know enough yet to answer what's the minimum value?
Yes.
No. Well, we have a little work to do, right? If I say where is the minimum at x equal 2? What is the minimum? What do I have to do? Plug it in. And of course, we already plugged it in. So that's what is the minimum value. That is where is the minimum value. That's come up already a few times with what do they want from you, x's or y's? Okay. Maybe. I know I say that all the time, I'm sorry. Okay. And make sure, blah, blah, blah. I sort of had notes that I have not referred to. Oh, that's right, I want to do this one. Let me see, where is it? 404. That didn't work. On page 3. Well, that got close. All right, 404. Nice up. 403, almost. So close. All right, here we go. Oh, what do they want from me on this one? I forget. I want to do this one. Yeah. Blah, blah, blah. Oh, yeah. Okay. So I want to write this guy's equation. I want to write the equation for this parabola, right? Well, funky. Let me see. Let me show the people at home what's happening. Oh, watch out. Okay. All right, this kind of sucks a bit because, well, let's see. What can you just tell me from the graph of that? Let's see if I can do this. I think I can do this. Capture. Say again, sorry? Yeah, I think I can maybe do this. No, maybe. Maybe, okay, we'll see. What's the really important thing you can tell me about that parabola?
The vertex.
Vertex, where's the vertex?
Negative 2, negative 3.
Yeah, negative 2, negative 3, I love it. So, can you, here's the general form. What can we fill in already? Let's see if you guys get this right. What can we put in? What do we know already? We know the vertex, negative 2, negative 3. Where do those go? Or where do we get them from so we know where to put them?
Maximization for this guy.
So what would go here? -3. Now be really careful. What would go here?
Plus 2.
Yes, because what is h? -2. Minus -2 is +2. And we know if it goes back 2, that's got to be +2, right? Am I finished? You're all like, if we're allowed to just say, yeah, that's yes, we're done. No, I don't know what the hell A is, right? This is not an equation yet. I don't know what A is. How the hell am I going to figure out what A is? I don't know, Jeff, man.
Test against a point.
Say again?
Test against a point and adjust.
Okay, I think maybe I understand what you're saying. Doesn't this equation have to define this graph? So that means that any point on this graph must work in that equation. What's one of the nicest points on this graph would be this one? What point is this? 0, -1. So 0, -1 has to work in this equation, yes? So when the input is 0, the output must be -1. Do you guys see that? And then I can just solve for A. Maybe. So you are going to see some of these in the homework. They're going to give you a graph. And you're just not going to know what A is. I know A is a positive or negative. It's obviously going to be. Is A going to be positive or negative? Opens up. So is A going to be positive or negative? Positive. Yes?
Can we use the vertex to plug in for X and Y?
The problem with that is that's how you got these parts. So if you put a -2 in, this is 0. So then A disappears.
Okay.
So that's a good point. You don't use a vertex because that'll make this part disappear, and then your thing you want to solve for goes away. Good question, though. And how I solve this for A? Well, I add 3, right? Is that cool? 0 plus 2 is 2 squared is 4, and then I divide by 4. So A is 1/2, and then I just throw a 1/2 there, and then I'm done. And again, we used the idea that the function must work when I plug points in that the graph goes through. That's what we did. We plugged in a point, the function's got to work, so I should be able to figure out what A is to make it work, which is essentially what I think you were saying. Okay. Maybe. Okay. Yeah. Maybe? Okay. Okay. So we got parabolas, we got standard form, we got various ways to find the vertex. Let me give you kind of not a word problem really, but a little more real life problem. What if my company, here's my company's profit function, yes? Here's my company's profit function. Let's see if I can make it make physical sense. That'd be awesome. Yeah. You like it so far?
Yes, we love it, Jeff. Shut up.
400x. Should be minus, no, plus is, it's a little weird trying to make, yeah, okay. Sure, we'll do that. Yeah, that makes sense. Yeah. So this profit function, so obviously the output is profit, and the input would be number of items sold. You got it with me? Number of items made and sold. So this, business, I am not a business person. I hated every single business course I ever took. Even though some of you guys might say, it's all math. No, it's not math. It's weird, stupid shit. Anyway, sorry. If you love business, I'm sorry, you love business. We need business people. It's not me. But I at least know this. Profit is revenue minus cost, right? So that's where this function came from, is they took a function for revenue and they subtracted the cost function. Why does this make physical sense? Does this open up or down? Opens down, which makes physical sense because there should be kind of like a sweet spot where you make the most profit, right? Now there are other variables in real life, but this is basically what they do. They're constantly analyzing demand and supply and so forth, and they're considering what do we want to set our price at and so forth to make the profit the most, obviously, right? Okay. So I want to find how many items must be make and sell so that I can make my profit the most. So of course, what does that really translate into mathematically? Finding the vertex, right? So here I want to find the maximum profit. It's a down parabola, so finding the vertex will be the maximum profit. So how do I find the vertex? Do you want to complete the square? I don't either. So let's do the better thing. What can I do to find the vertex real quick? Yes, to find the x piece. What is b? 400. What is a? Now I know you guys have a calculator. I always know you have a calculator. But let me just show you something real quick. So the negatives cancel, right? Watch this. 1, 2, 1, 2. So it's 40,000 divided by 2, 20,000. You can verify. Plug in the calculator and verify that you get 20,000. So what does that mean right there by itself? What does that mean?
Your maximum profits are 20,000 units.
Oh, say it one more time.
Your maximum profits are 20,000 units.
So the maximum profit occurs when we make and sell 20,000 items. Are you guys with me? Now, in the real world, you would make more than you sell. You have storage costs, right? There's other variables for the actual equation they use, and their equations normally look like this. So you have multiple peaks, multiple profit, multiple, anyway, we're not going to do, don't forget. But in the real world, things aren't parabolic, but they do have highs and lows the same way that parabolas do. What if I want to know what that profit is? How do I figure out what that maximum profit is? So what do you mean solve? You know x, so you just plug it in? Yeah, and solve for y, I like it. So you would just plug 20,000 in. Sounds exciting. What would that be, Jeff? 4,000,000,000,000. Holy shit, it's gonna be a lot. Oh, negative. Oh crap. I might have made this company. I think I made this company have a negative profit. It has a bad business model. Oh well, too bad for them. I don't know, somebody can verify. If you plug a 20,000 in, I'm very curious what this comes out to be. Right, so do negative 0.01 times 20,000 squared plus 400. Oh, okay, this is gonna be okay, Jeff. You just have to think a little bit ahead. I think it'll be okay. Yes. Let me think ahead a little bit. I think it'll be like 39,800, maybe. Let's see. Is anybody doing that for me? You guys have calculators? I think it is plus negative that plus 8,000,000,000. Yeah. 200. Oh, so it's gonna be holy shit and a half, Jeff. Millions. Okay, millions. Okay, I was off a little bit. So it's gonna be 3,999,800, maybe? I don't know.
Yep.
Yes?
Yep.
Okay. I think they're doing okay. Well, it depends. Okay, maybe. This is like, Jeff Bezos calculating his salary for about 32 seconds. Okay.
They might even be able to afford a broken arm.
Huh?
They might even be able to afford a broken arm without insurance.
Maybe. Okay. Is that cool? So you are gonna see, they're gonna give you real life problems, and when they say find the maximum, find the minimum, it really just means find the vertex, because that's where max or min occurs. And now we have this fantastic shortcut to find the x piece of any vertex. That kicks so much butt. All right, one last thing, and then I'll let you guys out of here. So help me remember this. X squared, okay, we know what that looks like. What do you do, Jeff? X cubed. Does somebody remember what that looks like? Okay, I like it. So a colleague of mine calls it giraffe graph because if you put a leg, it looks like a giraffe, and I'm always joking with him because I'm like, well, that giraffe, is he bleeding out? Somebody cut his leg off, but oh, poor little dude. So I call it a cubish. It looks cubish. So what's really interesting is every function that's x to an even power looks like this. Every function that's x to an odd power looks like that. Let me show you one thing. Shit, of course I'm still pointing to you a little bit. That's right, I want you to point there now. If you're at home, I'm really sorry. I want to show you something really cool. Two things that are really cool with what I'm about to show you. Have you ever heard of Desmos?
No.
Yes.
So Desmos.com. Is there any difference between that and this? No. Okay. Desmos.com is a beautiful graphing website that we would probably use if we had enough computer labs. But we don't, so we use TI calculators. So first off, look up here. This is x squared. Y equals x squared. Watch what happens if I make it x to the fourth. What happened? Squared, fourth. Squared, fourth. What's happening? Can you guys see that well enough? Squared, fourth power. What's happening? It's going faster up, correct? But what's happening to its bottom part? It's getting flatter. So watch this. I'm going to make it go crazy. You ready? 6th power, 8th power, 10th power, 20th power. What does it basically look like? Looks like a U, right? Instead of a, looks like not a U, but like a. But if I zoom in on it, it's going to look like a straight line. Isn't that crazy? All right, and the reason that's happening, I'm raising it to the 20th power. So something like 0.1 to the 20th power would be 1/10 to the 20th, which is 1/10 to the 20th. Holy shit, that gets tiny. What's 0.9 squared, for example? Anybody know what 0.9 squared is? Say again? 0.81. Multiply by 0.9 again, it's 0.729. Multiply by, so it's, see how it's getting smaller and smaller and smaller. So if I do 0.9 to the 20th, see how 0.9 is almost 1? If I do 0.9 to the 20th, it's going to get really small. If I do 0.9 to the 40th, then it's going to really look like, right? It's not going to be our, oh yeah, it's going to be bam, bam, right? Okay, that's a little funky. We're not used to seeing that because we're not used to using 20th powers, right? But it still fundamentally has that U shape to it. Now, let me turn this on. Here we go. Right now, let me make this a cube. Okay, look at all this. This is such a cool program. Let me see. See how I have B, C, D, F, G, H? I just want to make the D 1. So then I have my x cubed. There's x cubed. Right, there's my good old x cubed. And now if I make B 1, I'll get x to the 5th. See how they're basically the same shape? Just flatter in here. Okay, maybe. Now watch what happens if I turn some of these other pieces on. Let me go this way. Yeah, that looks good. Look at that weird shit. Okay. There we go. Now we're talking about some stuff. All right, that is still a 5th power. Now, real quick, what stayed the same? What stayed the same? Let me do this. I'm gonna make you. Let me make you go. Yeah, sure. I'll make you. I'm gonna make you go. Go. No, stop. Stop. there's my x to the 5th. And this, I really want you to understand what I just did. Isn't the green line now x to the 5th plus x to the 4th minus 0.7x cubed minus 0.1x squared minus 0.8x minus 0.6. I mean, it's all that crap, right? Isn't the green line very different from the red line? Of course it is, because now it's got all the extra stuff. What is the same about both of them? What's the red line start doing? What's it do at the beginning of it? Goes up. What's the green line doing? What's it do at the end? The red line eventually starts going up. What's the green line doing at the end? Going up. Now the green line does all kinds of weird shit in the middle, correct? But if I have x to the 5th is my highest degree, it's going to go up over here and it's going to go down over here. That's what it's always going to do. It can do weird stuff in the middle, but it's going to do this at the ends, and that's what we call end behavior. That's the end behavior of it. So no matter what I do, so all the other stuff here, change that, change that, change this, isn't it still starting by going up and ending by going up, and then it ends by going up still at both ends, right? So it's going up. You see from your perspective, it's going up, and then it's still going up, and it's doing weird stuff in the middle. So every x to an odd power will go up, do weird shit, go up. The end behavior will be up here and up there. Every even power is going to be up on that side, up on that side. Right? So if I turn off, let me see if you guys can feel this. How do I turn off the 5th power? I just make b 0, yes? Make b 0. Make these other things something a little less freaky. Okay, that's good. Like that. That's freaky. We're going to bring this up. There we go. Let me make this a 4th power. So the red line is just x to the 4th, and the green line is 0.7x to the 4th plus 2x cubed plus 1.3x. It doesn't matter. The highest power is a 4th power, correct? So in the middle, the green line's doing weird shit. And this guy's like, what are you doing? At the ends, though, don't they both end by going straight up on both sides? So end behavior doesn't care what the lower powers are. At the ends, it'll always do the same. X to an even power will always do this. X to an odd power will always, let me think from yours, will always do this. So that's what we call end behavior. That's going to be the first step in a graphing problem, is we just want to know what's it doing at the ends. And then we have to fill in what all the middle stuff is. Okay. All right, I think that's enough. That's enough for today. All right, I spoiled you by letting you out so early. Don't get used to that.